Assalamu alaikum, students. Hope you will be fine. As I promised you to give you some important information about these horrible questions, in my first series of videos, I have solved few questions which were related to potential dividers, I mean series circuits. Now, in this series of videos, I have selected few questions which are entirely covering all the areas of series and parallel. Here, this is one of the questions. In this question, it is said that each resistor of 1 ohm resistance is actually connected as shown in the figure. The current passing through the end resistor is 1 ampere. What is the potential difference across V across the input terminal? I have to solve it one step by step. So I have to show you that in this all we have to name these resistors. Let's say this is your resistor A, this is your B, this is your C, this is your D, this is your E, and this is your F. And by this all, we will reach to this point of calculation. So in resistor A, B, the current is 1 ampere. Then resistor C is in series with first two. Then resistor D is basically in series with the combination of A, B, and C. And then resistor E is in parallel with the combination of A, B, C, and D. And then resistor F is basically in series with the combination of resistor A, B, C, D, and E. So this is one of the plan to solve that question. Now I will solve this from a, from one side. I will start it from one side. Let's hide the unnecessary parts of the um, of this resistor. Here the resistors shown, they are A and B. So now till this point, these two resistors are in series. So your total resistance for these two is 2 ohm. And the current flowing through these 2 ohm resistors is equals to 1 ampere. Now, let's reveal the further resistors. Now there is resistor C. This resistor is basically in parallel with this. It means at this point, let's call it junction X. Here current is divided into two parts, here and here. And basically this current is coming from this resistor D. That is coming from this resistor D. So here I'm going to explain you till here that from D some current is coming. Let's say whatever the direction of the current is, sorry, whatever the amount of current is, this is I, and this current is divided into two parts here. One part is going through resistor A and B, whose combined resistance is 2 ampere, and some of that part is coming from resistor C, whose resistance is 1. So according to the concept of uh, Ohm's law, or resistance and current, if 2 ohm resistor allows 1 ampere current, then 1 ohm resistor must allow 2 ampere current. So this is an inverse relation, that more the resistance, less will be the current. It means the current flowing through this resistor C is 2 ampere, and current flowing through these two resistors, I mean this current, that is 1 ampere. So overall current which is being led from this resistor, I have named this resistor D. The current through resistor D is basically here 2 plus 1, which is equals to 3 ampere. Now this 3 ampere current is flowing through a certain resistance, and as I told you that here I will cover this area, that area which is visible to you, there are two resistors in series, so its total resistance is 2 ohm. Now this third one is in parallel with that, so I can calculate the overall resistance of this all area which is visible to you over here. That is R1 times R2 divided by R1 plus R2. So R1 your 2 2 times 1 divided by 2 plus 1, so it would be 2 by 3 ohm resistance. So it means this open area, or which the area which is visible to you, it has a resistance of 2 by 3 ohm. Now if I say that this resistor is also in series with these two, so this resistor is 1 ohm. So overall resistance till this point which is exposed to you, that is 2 by 3 plus 1, because this resistor D is in series with all the combinations as I told you earlier. So R equivalent, or R till this point, is actually 5 by 3 ohm. Okay, 5 by 3 ohm can be written as 1.67 ohm. It means that the equivalent resistance of resistor A, B, C, and D, that is 1.67 ohm. Now, in 1.67 ohm, if resistance is 1.67 ohm, the current flowing through this 1.67 ohm is 3 ampere. This is the information which is yet revealed till this point. Now I'm going back in this way, and while moving back, my this resistor is in the path. This resistor is basically the resistor, this one. This is resistor E. So when I say that I have to consider resistor E as well, so resistor E is actually in parallel with this 1.67 ampere. So I can say that overall resistance of whatever is visible to you all, that is I'm going to calculate over here. It is basically resistance of resistor A, B, C, D, E, and F together, that is equals to 1.67 times 1 divided by 1.67 plus 1. So this is the resistance. That resistance gives you the value of 1 point. Let me calculate from the calculator. 1.67 divided by 2.67, it gives us 0.625. So it is 0.625 ohm. So it means whatever is exposed to you, its overall resistance is till this point. This is your, let's say, junction Y. So till here, R equivalent is 0.625 ohm. Now, very important point, that is that if this resistance is, now I'm going to release this all for you because there is no need of this cover. Now if 3 ampere was the current passing through the resistance of 5 by 3 ohm, right here I have written this all, that 3 ohm 3 ampere is the current which is passing through 1.67 ohm, then what would be the current flowing through this resistor I? Again I can calculate in that way, that I1 divided by I2 is equals to R2 divided by R1. So I1 is your 3.1. What is your I1? I1 is 3 ampere, I2 is unknown, I have to calculate through this. Then R2 is 1 ampere, 1 ohm, and R1 is 1.67. So from here I can calculate this one, that it would be I2 will be I2. I2 means the current in resistor E. Let me call it IE rather than writing I2. That is current in resistor E. That is 3 times 1.67. So it gives us 5.0 ampere. It means the current through this, that is 5.0 ampere. Now at this junction I would come back to this point here, that if resistor F is feeding the whole circuit beyond junction Y, then the resistance of this all circuits is basically 1 plus 0.625, which is actually 0.625 is beyond this junction Y, and then 1 ohm is of the resistor F. So total resistance of the circuit is now 1.625 ohm. Now this is one mystery solved, that total resistance of the circuit is 1.625. Now, what is the current flowing through? As I told you, that current is basically split it into two parts. This current is current through E, it is 5 ohm, and the rest of the current which is through here, it is 3 ampere, it is 5 ampere. So total current in this resistor is 8 ampere. So it means 8 ampere is the total current. So I have figured out all the values almost. So V is equals to I times R will be used finally. I is your 8 ampere and this R is 1.625. So let's check this one out, that 8 times 1.625, that gives you exactly 13 answer, 100% 13 volt. Okay, so this is the solution of this mysterious question. I have solved this question with another method here. These all are the calculations which are basically separately done for you. They all leads us to the same answer, but it was a long method, so that's why I selected this one, that a short one. So this is, although this all is jumbled up, but I hope that if you will follow this video, it will help you out to understand it.